Hi, ma'am. So this is Vishweshwaran going to continue with the question two. So what is question two is about? So question two is about, let me give a simple introduction. Create a unique real life or logical scenario involving at least three to four conditions slash inputs can be sensors, switches, decision or rules. In a simple way, which I can explain is how we're going to combine a discrete math theory with a real life scenario. So let me give my idea, which means my group idea is digital lock magic. So digital lock magic has certain rules to open the lock. So what is that? Okay. Number one, we are given a digital lock with four sensors called as A, B, C, and D. The lock will open if the Y equals to 1 based on rule 3. Okay. So what are the rules? When I'm talking about rule. So let me give introduction for the rule. What is rule 1? A is active, which means A equals to 1, or B is inactive, which means B equals to 0. Boolean expression A plus B bar. What is rule 2? C is inactive, C equals to 0, or both A and D are active, which means A equals to 1, D equals to 1. What is the Boolean expression? Boolean expression equals to C bar plus A times D. And what is rule 3? Because rule 3 is important on this particular lock, which means the lock won't open if B and C are both active, which means B and C equals to 1, unless D is also active, which means 1, 1, 1. So what are the Boolean expression? B times C times D times bar, bracket, and also bar. So this is the final Boolean expression. So let me go to question 2. Boolean expression for Y. So in this particular question, a question stated we have to combine. So how I combine is, this is rule 1, and this is rule 2, and this is rule 3. So which means y equals to bracket a plus b bar times bracket c bar plus a times d times bar bracket b times c times d bar. So in a simply expression using Boolean algebra. On this particular thing, how I'm going to simpler this formula using De Morgan's law. So what is De Morgan's law? So this is the simple explanation I given for myself to understand what is De Morgan's law and also for the presentation. Okay. So De Morgan's law is the negotiation of A and B is the same as not A or not B, which means B times C times D is equals to same with B bar plus C bar plus D. So this is the De Morgan's law. So by using De Morgan's law, I can simplify this formula is the final output is Y equals to bracket A plus B bar times bracket C bar plus A times D times bracket B bar plus C bar plus D. So these are the final output for the question 2. Okay, let me continue with question 3. Why so long? Okay. So make it simple. So we have to use this to verify that the logic works correctly by constructing a four variable Karnaugh map. So before using Karnaugh map, I just use the truth table. So which means I'm using 16 variables. So as you can see, A, B, C, D, B bar, C bar, A plus B bar, A times D, C bar plus A times D, B bar, C bar times D, and finally you can get Y. So this is my Karnaugh map. Okay. So the Karnaugh map state that, hence the Karnaugh map confirmed that the Boolean expression Y equals to bracket A plus B bar times bracket C bar plus A times D times bracket B bar C bar D matches the logic defined by the truth table. So the truth table is the same as the Karnaugh map. So how to do the truth table? And they have rules and regulations for the truth table, which means and or. That is the particular rules got for and table and particular rules for or table. By using that, you can get the truth table. So above one is the truth table and below one is the cutoff map. So continue with the question 4. Draw a logic circuit diagram based on your simplified expression. So based on the rules, I have to explain how the expression can be changed into logic diagram. As you can see, A go to the this one and B go to the B bar. Then both plus using this diagram. So A plus B bar. So this one is A plus B bar. And this one C bar and this one A D. So A and D can be times. So the final output is C bar times with the A times D. So C bar plus A times D. So as you can see, C bar here, go here, then this is the symbol for the OR table, I mean OR diagram. And this one symbolically the N diagram. So C bar plus with AD. So which means A times D. So I can say that AD. And this particular thing, you can see B bar, B bar, C bar. So B bar, C bar, and D combined together and its times. So this is the N table, N diagram. So which means this one on this side, this one on this side, this one on this side. At the final thing, they all times. And at the final, you can get Y. So these are the logic circuit diagram based on your simplified expression. So for more simpler, so this is the OR diagram. Maybe it's be look like this because I'm drawing on this. And this is an diagram. Yeah, it will look something like this. Yeah. Okay. So or means we have to plus, then and means we have to times. So A plus B, C plus AD, and B, C, D. At the final expression, we can get Y, which is this one. So this is E. Then the next, I would like to continue with the final question. Okay. System explanation. First, I talk about the rule. Second, I talk about expression. Third, I talk about truth table kind of map. Fourth, I talk about logic circuit. Why are I doing this? So this is the simple explanation. The digital log system operates using four sensors, as I told before, A, B, C, and D. The first condition ensures the system is flexible. The log opens if the sensor A is active or B sensor B is inactive. So on the logic circuit, this means the A should be 1 and the B should be 0. So A plus B should be you get 1. Okay, something like this. And the second condition checks either that sensor C is inactive or both A and D are active together, allowing redundancy. The third rule condition blocks access if the both B and C are active without D being active to security safeguard. So these are things we did for the protection of the logging system, which means the third condition blocks access if the both B and C are active without D, which means the D is 1, C equals to 1, but the D equals to 0. So based on the OR table, 1 times 0, you will get 0. So rule 1 pass, rule 2 pass, but rule 3 equals to 0, which means the log won't open. So that's why this is the scenario I given. Okay, let's say the test one, A equals to 0, B equals to 1, and C equals to 1, and D equals to 0. Okay, rule 1. From here you can understand the system correctly. So A equals to 0, b equals to 1 so that b bar equals to 0 because the bar is always opposite of the b. So a plus b bar 0 plus 0 equals to 0. So if you get 0, it's obviously fail. So the operation 1 is fail. We put x over here. Okay. Rule 2, c equals to 1. So c bar equals to 0. So a equals to 0, b equals to 0 based on this scenario. Okay. So that c bar, which means 0 plus a times d, obviously 0 times 0 equals to 0. And the final one, 0 plus 0 equals to 0. So this also gets 0. So operation 2 also fail. Rule 3, b bar equals to 0, c bar also equals to 0, d bar equals to 0. Obviously, that's also fail. So do you think the lock will open? Obviously, no, because rule 1 failed, rule 2 also failed, rule 3 also failed. So the lock won't open. The lock won't open, so what is the function of the lock? Okay, now we go to the function, how the lock works. Okay, with this scenario, a equals to 1, b equals to 0. Okay, so you mean a equals to 1. A is active, b is inactive. So b bar is active. So a plus b bar equals to 1 plus 1, 1. Okay, rule 1 pass. C bar is inactive. C is inactive. C bar is active. So A times D, which means active plus active times active equals to 1. So based on n table, 1 times 1 equals to 1. Okay. And the final one, C bar equals to plus A times D. So 1 plus 1 equals to 1. So based on the rules given and based on discrete theory, the second condition is pass. And last but not least, B bar is active, C bar also active, D bar also active. So 1, 1, okay. So B bar plus C bar plus D, 1 plus 1 plus 1, the condition 3 also pass. Pass, pass, pass. So the lock will open from like this to this. Okay. So the lock will open. So this is how the discrete math theory is combined together with discrete math theory with a real life example. So thank you so much. So bye from this Vishwar.